Okay, so before we move on, I want to say a little bit about logical equivalency. Um, Both because this is going to be really important in translating sentences into logical form, into sort of the propositional logic language, and also because it's going to be, useful later on when we're trying to prove stuff. So anyway, it's useful with translating sentences because you might run into a problem. How would you translate these sentences? Neither Asha nor Balon love Cersei. Neither Bob nor Diane is in the room. Now, one way you might do this is not A and not B, and, for the Bob and Diane one, not B and not D. But another way you might think of doing this is what about not symbol parentheses A or B and, not symbol B or D. Wouldn't that be another way to translate this, right? You have this neither nor. Well, you know, that might set you up for an or. Which of these is right? Well, both actually are. You might be asking yourself, well, how can that be, right? The whole point of logic is we're supposed to be precise, supposed to be exact. How can there be two equally correct ways to translate the same sentences? Well, the reason that can be is because, in a very real sense, not A and not B is saying exactly the same thing as not parentheses A or B, and not B and not D is saying the same thing as not parentheses B or D. In a very real sense, they have exactly the same meaning. And what sense is that? Well, in the sense that we're interested in logic, they are logically equivalent. So what does logically equivalent mean? Two formulas are logically equivalent when they always have exactly the same truth values. And what that means is whenever one is true, the other is true, and vice versa. And whenever one is false, the other one is false, and vice versa. Look, let's look at our truth table. I think this will make this a bit more precise, right? So, when we have the A and B, this way of setting it up gets every possibility. And look, not A and not B always has exactly the same truth value. You might want to say, put this in more sort of computer language or machine language, has the same output as not parentheses A or B, right? Every single line here, both of these are false except for the last one. Both of these are only true when both A and B are false, right? For the A or B in the parentheses, that might be a little harder to see, right? But think about it. You do everything in the parentheses first, and basically the not symbol just flips it. Well, A or B is true in every case except where A or B are both false, but remember the not symbol flips it, so we end up with false in every case except where this A or B is false, and then it's true, right? These two sentences, or these two formulas, are logically equivalent. They have, whenever one's true, the other one's true. Whenever one's false, the other one's false. Vice versa in both cases. They are logically equivalent. If every single line of your truth table, two formulas have the same truth value, the same sort of output, whenever one's false, the other one's false. Whenever one's true, the other one's true. As you can see here, they do. Then those formulas are logically equivalent. For purposes of logic, they mean the same thing. Now, what that means is Either answer is right because in a very real sense, they're saying the same thing. Or also take this one, right? Either Bob or Diane is not in the room. One answer here would be not B or not D, right? Either Bob is not in the room or Diane is not in the room. But what about not B and D? Slightly less natural translation to my mind, but it's also a possible answer, right? Well, again, which one is right? Well, again, both are, right? They have exactly the same truth values. Look at our truth table. The only case where these are both false is our first line, where Bob and Diane are both in the room, right? Every other line, both are true. We can see that they're logically equivalent. And look, it doesn't matter what letters you use. You can replace this with A and B, X and Z, whatever. It's just the formula here, not one letter or not another letter, has the same truth value as not parentheses one letter and another letter, right? So these are logically equivalent. Either one is correct. Now look, to my mind, not B or not D is a slightly better translation for either Bob or Diane is not in the room, right? The sentence itself has an or, the little v represents an or. I like this just a little better. And to my mind, not, parentheses B and D is a slightly better translation for Bob and Diane are not both in the room. But, because this one has an and it seems to get that a little better. But either is correct, right? Because for the purposes of logic, they have the same truth value. Always, every line of the truth table, these say exactly the same thing, have exactly the same output, means they're logically equivalent. You can use either one. Now, this will be important later. This will actually have some kind of cool and interesting results. One interesting result here is if two formulas are logically equivalent, you can always just replace one with the other. Trust me, that will be important later. You might say, well, why is that important? Actually, especially when we start talking about conditionals, which I will in the next lecture, this will actually have some important results.